Welcome to another deep dive.
Yeah.
Today, we're going where reality itself starts to get a little fuzzy.
Oh, yeah.
We're going to be looking at the limitations in the universe.
Right.
Those fundamental kind of rules of the road
Yeah.
that even science fiction,
Yeah.
and even the wildest sci-fi can't completely ignore.
It's really interesting because we often think of limitations as something imposed from the outside, but the things we're talking about today,
Yeah.
these are different. These are built into the fabric of reality itself.
That's what's so fascinating to me. We're not talking about
Right.
technological hurdles or, things that,
Exactly.
that we just haven't figured out how to overcome yet.
Yeah.
These are like the universe itself saying, nope, this is as far as it goes.
Mhm.
And, one of the biggest ones that we're going to unpack today
Yep.
is Heisenberg's uncertainty principle.
Yeah.
This is, it's like the universe saying you can't know everything
That's right.
with perfect certainty, no matter how hard you try.
Yeah. And it's less about the universe being deliberately obstructive and more about a fundamental truth about the nature of observation at the quantum level.
Okay.
So if you imagine that you're trying to measure the position of an electron,
Yeah.
you need to interact with it somehow, right?
Or-
Maybe you bounce a photon off of it,
Yeah.
but that interaction, no matter how delicate, changes the electron's momentum.
So it's not just our instruments
Sure.
being clumsy. It's
That's
the
it.
act of measuring itself.
It's not our limitations. It's the nature of reality. So
Yeah.
the more accurately you try to pin down an electron's position,
Uh-huh.
the less you can know about its momentum and vice versa.
Yeah.
It's as though the very act of observation
Yeah.
nudges the universe into choosing one aspect to reveal,
Okay.
leaving the other shrouded in a kind of quantum fog.
Which has all sorts of implications for how we,
Right, yeah.
think about the universe and how we think about reality.
Huge implications.
If
Yeah.
we can't perfectly measure even the tiniest of things.
Yeah.
The tiniest building blocks.
Right.
What does that say about,
Uh.
our ability to predict and understand
Yeah.
the world around us?
Those are some of the really big questions
Yeah.
that arise from Heisenberg's uncertainty principle.
Is there an inherent randomness
Right.
to reality?
Big question.
Yeah.
And while it might seem unsettling to some, it also opens up a realm of possibilities.
Yeah.
I mean, it tells us that the universe isn't a deterministic clockwork.
Right.
There's an inherent fuzziness
Okay.
at the quantum level that leaves room for the unexpected.
So we've got this fundamental uncertainty
Yeah.
baked into the universe at the smallest scales.
Uh-huh.
But there's another big limitation that we have to grapple with.
Right.
And this one applies to everything,
Yeah.
no matter how large. And that's the speed of light.
Absolutely.
The ultimate
It's a speed limit.
cosmic speed limit.
Yes. And it's more than just how fast light happens to move.
Mm-hmm.
The speed of light, approximately 299,792,458 meters per second, is a fundamental constant in physics woven into the very fabric of space-time itself.
Okay, so
Yeah.
what does that mean that it's tied to space-time?
It's a fundamental aspect of the universe's architecture.
Like, we all know that nothing can go faster than light,
Uh-huh.
but WHY?
Well, think of space-time as a four-dimensional fabric
Okay.
with 3 dimensions of space and 1 dimension of time.
Yeah.
The speed of light isn't just the speed of a massless particle like a photon.
Right.
It defines the relationship between space and time.
Okay.
It's the speed of causality.
Right.
It's the speed at which information can travel,
Ah.
and cause and effect can ripple through the universe.
So if something were to travel faster than the speed of light,
Right.
it would be like sending a message back in time
That's right.
and potentially messing up,
Yeah.
the order of cause and effect.
That's one of the paradoxes.
Like, you could arrive at a destination
Yeah.
before you even left.
That arise if you try to imagine breaking the speed of light barrier, and it leads to all sorts of mind-bending possibilities,
Yeah.
like the idea of closed time-like curves,
Okay.
where you could potentially travel back in time
Right.
and meet your younger self.
Yeah.
But even if such things were theoretically possible, there are still the immense energy requirements to consider.
Right. Because even approaching the speed of light
Right.
requires massive amounts of energy,
Yeah.
far beyond what we can currently achieve.
Uh-huh.
So for all practical purposes,
Yeah.
the speed of light is a hard limit on how fast we can travel
Yeah.
and how quickly we can communicate across vast distances.
It sets a boundary on our exploration of the universe.
Yeah.
A boundary that might seem frustrating, but also sparks our imagination.
Makes you think about how incredibly vast the cosmos is.
Right.
And, whether we'll ever be able to grasp it.
It does.
It also, when you think about astronomy
Yeah.
and you look at these distant galaxies,
Right.
you're looking at light that has traveled for millions or even billions of years.
We're literally looking back in time. We are. But that's a conversation for another deep dive.
Indeed. For now, let's shift our focus to another realm where limitations and possibilities intertwine, the quantum world.
Okay.
And this is where things get really strange, even for physicists who've spent their careers studying it.
No, I'm ready for strange. I've done a lot of reading about quantum mechanics, and
Yeah.
it still feels like my brain is doing backflips trying to
That's hard.
grasp it. But let's try to unpack some of the key concepts.
Okay.
What about this idea of wave-particle duality?
Yeah.
How can something be both a wave and a particle at the same time?
This is one of the central mysteries of quantum mechanics, and it challenges our everyday intuition about how the world works.
Yeah.
We're used to thinking of things as either waves like ripples in a pond or particles like tiny marbles.
Right.
But at the quantum level, things aren't so clear-cut.
So an electron, for example, can sometimes act like a wave and sometimes act like a particle. It's more accurate to say that it exists in a state that has both wave-like and particle-like properties.
Okay.
Think of it like a coin spinning in the air.
Uh-huh.
Until it lands, it's neither heads nor tails.
Yeah.
It's in a superposition of both states.
Okay.
Similarly, an electron exists in a superposition of wave and particle states until we try to measure it.
And then that act of measurement forces it to collapse
Right.
into one or the other.
That's the current understanding.
Okay.
It's as if the act of observation forces the quantum world to choose between possibilities.
Uh-huh.
And this leads to all sorts of mind-bending consequences.
Like the double slit experiment,
Like the famous double slit experiment.
where you fire electrons at a barrier with two slits,
Uh,
and it creates an interference pattern.
Yeah.
As if they're passing through both slits simultaneously like waves.
exactly.
But if you try to measure which slit it goes through,
Yeah.
it acts like a particle,
It does.
and the interference pattern disappears.
It's as though the act of observation changes the very nature of reality.
It really makes you question what it even means
It does.
for something to exist,
Right.
independently of our observation of it.
Huge question.
It definitely makes you think, but there's another aspect of quantum mechanics
Yeah,
that's even stranger than that, and that's quantum entanglement.
that's right. This is the spooky action at a distance stuff.
Yeah, where two particles
Uh-huh.
can be linked, even if they're light years apart.
Quantum entanglement is one of the most mind-boggling concepts in physics.
Yeah.
It's a phenomenon where two particles become linked in such a way that their fates are intertwined,
Yeah.
no matter how far apart they are.
Yeah.
If you measure the state of one particle, you instantly know the state of the other,
Oh.
even if no signal could have traveled between them at the speed of light.
So it's like two coins flipped at the same time.
Yeah.
You see one land on heads.
Yeah.
You instantly know the other one landed on tails,
Right.
even if they're miles apart.
Right.
But in the quantum world, it's not just heads or tails. It's more like they share a hidden connection
It's much weirder than that.
that transcends distance.
Imagine two electrons that have become entangled.
Oh,
Now, they could be light years apart,
Ah.
yet they share a connection
okay.
that allows them to influence each other instantaneously.
Yeah.
So if you measure the spin of one electron and find it spinning up,
Right.
you instantly know the other electron is spinning down, even if it's on the other side of the galaxy.
It's like they're communicating faster than the speed of light,
Right.
which we just established is impossible.
Yeah, that's the million-dollar question.
How does that even work?
And it's one that continues to puzzle. Physicists, Einstein himself called entanglement spooky action at a distance, because it seemed to violate the principles of relativity. But numerous experiments have confirmed entanglement, and it's becoming increasingly clear that it's a real phenomenon that we need to take seriously.
So we've got uncertainty baked into the fabric of the universe. At the smallest scales,
Uh-huh.
we have a cosmic speed limit that governs everything.
Yep.
And now this mind-bending entanglement
Right.
that seems to defy
Yeah.
our notions of space and time.
Just a lot.
It's almost too much to process.
It's certainly a lot to take in, but that's the beauty of physics.
Yeah.
It challenges our assumptions and pushes us to expand our understanding of the universe.
Right.
And the more we learn, the more we realize how much more there is to discover.
Yeah.
Welcome back to our exploration of the universe's fascinating world book.
In part one, we talked about some pretty mind-bending concepts.
Yeah.
Heisenberg's uncertainty principle,
Uh-huh.
the speed of light as like this universal speed limit,
Right.
and then this strange world of quantum mechanics with wave-particle duality and
Yeah.
quantum entanglement.
Yeah, it's a lot to take in.
Yeah, it is a lot to take in. I'm still reeling from the idea that the universe like has these built-in limitations.
Yeah.
But it's those very limitations that seem to give rise to so much complexity and wonder.
It's a beautiful paradox, isn't it?
Yeah, it is.
I mean, these limitations aren't just about what we can't do.
Right.
They shape what is possible.
Right.
What our universe looks like, how it behaves.
Yeah. So let's talk about some of the implications of these limitations.
Yeah.
For example, quantum entanglement.
Uh-huh.
That seems like something that could revolutionize communication.
Absolutely.
If we could harness it.
Imagine a world where communication is not only instantaneous,
right,
but also completely secure.
Okay.
Because entangled particles are linked.
Yeah.
Any attempt to intercept the information would instantly alter the state of both particles.
Right.
Alerting both the sender and the receiver to the eavesdropper.
Wow, that's amazing.
Yeah.
So like no more worrying about hackers or security breaches.
That's right.
This sounds like something straight out of Star Trek.
It does sound like science fiction, but...
Is this really feasible, though?
It's still early days. But researchers around the world are working on developing technologies based on quantum entanglement.
Okay.
One of the most promising applications is quantum cryptography, where entangled particles are used to create unbreakable encryption keys.
So instead of relying on like complex mathematical algorithms, that could potentially be cracked by somebody.
Yeah.
We could have security based on the fundamental laws of physics.
Exactly. It's a whole new paradigm for secure communication.
Wow.
And it has the potential to transform everything from online banking to military communications.
That's incredible. What about quantum computing?
Yeah.
I've heard that's another area where quantum mechanics could have a huge impact.
Quantum computers leverage the principles of superposition and entanglement.
Right.
To perform calculations in ways that classical computers can't even dream of.
Okay.
Imagine a computer that can be in multiple states at once, exploring all possible solutions to a problem simultaneously.
So what kind of problems could we solve with that kind of computing power?
The possibilities are almost endless.
Yeah.
Quantum computers could revolutionize fields like medicine materials, science, and artificial intelligence.
Okay.
They could help us design new drugs, develop new materials with incredible properties, and create AI systems that are far more powerful than anything we have today.
So these limitations that we've been talking about are actually opening up these new frontiers in technology.
It's like the universe is saying, okay, you can't break these rules, but you can use them to your advantage.
That's a great way to put it. Now let's shift our focus back to the speed of light.
Okay.
And while it might seem like a barrier to our exploration of the universe, it also provides us with a really powerful tool, and that's light itself.
Absolutely.
Because light travels at a finite speed.
Right.
When we look at distant objects, we're actually seeing them as they were in the past.
We are.
It's like having a time machine built into our telescopes.
Precisely, the farther away an object is, the longer it takes for its light to reach us.
Right.
So when we look at a galaxy that's millions of light years away, we're seeing it as it was millions of years ago.
That's incredible.
It is.
So by studying light from distant objects, astronomers can literally piece together the history of the universe.
Exactly. They can observe the formation of the first stars and galaxies.
Wow.
Track the evolution of cosmic structures and even search for clues about the universe's very beginnings.
It's amazing to think that the speed of light, which seems like this constraint, is actually like the key to unlocking the mysteries of the universe's past.
Absolutely. And it's not just about the past.
Okay.
The speed of light also plays a crucial role in our understanding of gravity.
Okay, you're talking about Einstein's theory of general relativity, where gravity is not a force, but a warping of space-time.
Right.
Caused by mass and energy.
That's the one. And the speed of light is intimately connected to this warping.
Okay.
It determines how much space-time curves around massive objects.
No, the speed of light, which governs the largest scales of the universe, is also tied to the very nature of gravity itself.
It's a beautiful example of how interconnected the laws of physics are.
Yeah.
And it highlights how a limitation, in this case, the speed of light, can be a fundamental ingredient in the grand recipe of the cosmos.
Which brings us back to the uncertainty principle.
It does.
So I've been kind of wondering about the implications of that.
Yeah.
If we can't perfectly know
right.
a particle's position and momentum at the same time, does that mean that the universe is fundamentally unpredictable?
That's one of the biggest questions in quantum mechanics.
Okay.
Does the uncertainty principle imply that there's an inherent randomness to reality?
Yeah.
Or is there some deeper level of order that we haven't grasped yet?
Some physicists believe in the many worlds interpretation of quantum mechanics, which suggests that every time a quantum measurement is made,
right.
the universe splits into multiple parallel universes.
Yeah.
Each representing a different outcome of that measurement.
It's a wild idea, but it's one way to reconcile the strangeness of quantum mechanics with our everyday experience of a single definite reality.
So countless parallel universes branching off.
With every quantum event.
Each
with its own set of possibilities and outcomes.
So in one universe, Schrodinger's cat is alive. And in another one, it's dead.
Exactly.
And in each of those universes, there's a version of us observing that particular outcome.
It's enough to make your head spin.
Yeah, this is a lot.
But it's a reminder that our understanding of reality is constantly evolving.
Right.
And what seems impossible today might become commonplace tomorrow.
This deep dive has been incredible.
It has.
My brain needs a moment to catch up. We've explored some really mind-bending ideas about the universe's limitations.
Yeah.
And how they shape everything from technology to our understanding of reality itself.
Yeah.
Welcome back to the deep dive in the last two parts. We really dug deep in the universe's rule book.
We did.
Those fundamental limitations that kind of govern reality at the most basic levels, from the uncertainty principle to the speed of light.
Yeah.
It's clear that even in a universe of vast possibilities, there are boundaries.
Absolutely. But as we've seen, those boundaries aren't just constraints.
Right.
They're the very things that shape the universe as we know it.
Yeah.
And they give rise to the complexity, the beauty, the sheer wonder that we find when we look out at the cosmos.
And it leads to some pretty deep philosophical questions, too.
It does.
I mean, if we can't perfectly know the present because of the uncertainty principle, does that mean the future is uncertain, too?
Right.
Does that leave any room for free will in a universe that's governed by physical laws?
That's a question that philosophers have grappled with for centuries.
Yeah.
And quantum mechanics adds a whole new layer of complexity to it.
Right, because if the outcome of a quantum event is truly random, does that mean that our choices, which ultimately come from, physical processes in our brains, are also random?
So are we just collections of particles following predetermined paths, or do we have genuine agency?
It's almost like asking, does randomness at the subatomic level translate to freedom at the human level?
Yeah, there's no easy answer.
Right.
It depends on how you interpret the implications of quantum mechanics.
Okay.
Some argue that even if individual events are random, the complex interactions within our brains create a level of emergent behavior where free will can exist.
Okay.
So think of it like a coin toss. A single coin toss is random.
Right.
But if you toss 1,000 coins,
okay,
you'll see a pattern emerge.
Right, a 50-50 split.
Yeah, a roughly 50-50 split between heads and tails.
So maybe it's similar with our brains.
Maybe.
The individual neurons might be firing randomly, but the overall behavior of the system, the choices we make, could still be meaningful and reflect our individuality.
Exactly. Like the difference between looking at individual pixels on a screen versus seeing the whole picture.
Right.
There's a level of organization and complexity that emerges at higher levels that isn't apparent when you're just looking at the individual components.
Okay, so free will isn't completely ruled out by quantum randomness.
Yeah.
What about time?
Okay.
Earlier we were talking about how the speed of light allows us to look back in time to see events that happened millions or even billions of years ago.
Yeah.
Does that mean that the past is fixed?
Okay.
And the future is predetermined?
Well, the nature of time is one of the biggest mysteries in physics. Einstein's theory of relativity showed that time isn't absolute.
Right.
It's relative to the observer's frame of reference.
Right. So what we perceive as simultaneous events might not be simultaneous for someone moving at a different speed.
That's right.
Or in a different gravitational field.
It might not be.
The whole idea of time dilation.
Yeah.
Where time slows down for objects moving at high speeds, it's mind-boggling to think that time isn't this universal constant.
Yeah.
But it's something that can be stretched and warped.
It can be.
But does that mean that the future is already written?
That gets into some really deep philosophical territory.
Okay.
There's a concept called the block universe theory,
okay,
which suggests that the past, present, and future all exist simultaneously. Think of it like a loaf of bread, where each slice represents a moment in time.
Okay.
The whole loaf exists at once, even though we can only experience one slice at a time.
So in that view, everything that has happened is happening and will happen, is already laid out like a cosmic film strip.
It's a deterministic view of the universe.
Yeah, that kind of makes me feel like a character in a movie.
Yeah.
Just playing out a predetermined script.
Some find that comforting and others find it unsettling.
Right.
But even if the future is already out there in some sense, we still experience it as a series of unfolding moments.
Right.
Each with its own choices and possibilities.
Right. And the question of whether those choices are truly free or predetermined might be one that we can never answer definitively.
It might be.
This has been a real head scratcher.
It is.
I appreciate you walking me through these ideas.
It's a pleasure.
It seems like every time we explore one aspect of the universe's rule book, it opens up a whole new set of questions and mysteries.
And that's the beauty of it. The universe is endlessly fascinating, and the more we learn, the more we realize how much more there is to discover. The limitations we've talked about aren't meant to shut down our curiosity. They're invitations to explore further, to push the boundaries of our knowledge and imagination.
This has been an incredible deep dive.
It has.
I hope our listeners have enjoyed the journey.
I hope so.
We've covered a lot of ground, from the uncertainty principle to the speed of light, from quantum entanglement to the very nature of time itself.
We have. It's been my pleasure to share these ideas with you and your listeners.
Well, thank you for joining us, and hopefully this has sparked some curiosity.
Yes.
And a sense of wonder about the universe and our place within it.
That would be fantastic.
And maybe even a little bit of existential angst.
A little bit.
But hey, that's part of what makes being human so interesting, right?
It is.
It's that ability to ponder these big questions.
Yeah.
Explore the mysteries of the universe and keep searching for answers, even if those answers lead to even more questions.
Exactly. The journey is just as important as the destination.
That's a great point.
And in the grand scheme of things, we're all just explorers trying to make sense of this vast and incredible cosmos.
Well, that's a great note to end on. Thanks for joining us on this deep dive.
My pleasure.
Into the universe's rulebook. Until next time, keep exploring, keep questioning, and keep looking up at the stars.
Absolutely.
With a sense of wonder.